Have you ever wondered what science actually is? I don't mean just a school subject or lab coats and test tubes, but really, truly, what is science? Where did it come from? Why do we trust to explain the world around us? And what makes it so powerful and yet so misunderstood? In this video, we are going on a journey. A journey not through equations or technical jargons, but through the heart of what science is. If you have ever been curious about how we know what we know, or why we sometimes change what we thought we knew, this is the guide for you. Because science isn't just a subject, it's a mindset, a method, a way of exploring everything from the smallest particle to the entire universe. So sit back, get curious, and let us begin with the most important question of all. What is science? Science at its core is the process of understanding the world through careful observation, questioning, and testing. That's it. It's not about memorizing facts, it's about asking questions and searching for reliable answers. Imagine a child who asks, "Why is the sky blue?" That question, that's science in motion. It's curiosity reaching out into the unknown, trying to make sense of what we see. Science is not a list of truths carved in stone. It's more like a flashlight. We use it to explore the dark, to shine a light on the unknown. And the more we look, the more we discover. It's a way of thinking that says, don't just believe it, test it, observe it, repeat it. It relies on evidence, not opinion, patterns, not coincidences. In fact, the word science comes from the Latin word scientia, meaning knowledge. But not just any knowledge. Knowledge gained through systematic study and repeated testing. And here is something important. Science doesn't care who you are. It doesn't matter if you are a student, a teacher, a Nobel Prize winner, or someone looking up the stars for the first time. Science is for everyone who is willing to ask why, and then do the work to find out. Science didn't start in a lab. It started when humans first looked around and wondered. When early humans tracked the stars to know when to plant crops, or noticed that boiling water could make food safer. That was science in action, even if they didn't call it that. In ancient Egypt and Mesopotamia, people recorded observations of the stars, plants and medicine. The Greeks, like Aristotle, began asking big questions about nature, motion and elements. They didn't always get the right answers, but they were starting something big. Fast forward to the Islamic Golden Age, scholars like Al-Hasan developed early ideas of optics and experimentation. In India, mathematicians invented the concept of zero. In China, inventors built tools like the compass and the seismograph. Science was growing across cultures, across continents. Then came the scientific revolution in the 1500s and 1600s. People like Copernicus, Galileo, and Newton changed everything. They weren't just observing the world. They were testing the ideas, creating laws of motion, and uncovering the structures of the solar system. They introduced something revolutionary, the idea that knowledge should be tested, not taken on authority, that observations and reason should guide us, not tradition or guesswork. Since then, science has exploded, from Darwin's theory of evolution to Einstein's theory of relativity, to modern discoveries like the human genome and quantum mechanics. But all of it started with the same thing, asking questions, testing ideas, being willing to change when the evidence demanded it. So now that we know what science is and where it came from, the next question is, how does it actually work? What's the engine behind it? That brings us to the scientific method, science superpower. It might sound technical, but don't worry. It's just a fancy way of saying, here is how we figure things out in a reliable way. Let's break it down. The first step is observation. This is where it all starts. You notice something weird, something interesting, or just something unexplained. Why do apples fall down and not up? Why does metal feel cold? Why do some people sneeze near flowers? That's the spark. Now the second step, asking questions. From that observation, we shape a clear, focused question. Something like, what causes sneezing during springtime? Now the third step, form a hypothesis. Now you make an educated guess. A hypothesis is your best shot at explaining what's going on, based on what you already know. Maybe sneezing is caused by tiny particles in the air, pollen. Now the fourth step, experiment. Here is where things gets hands-on. You test your idea with a fair, repeatable experiment. You might expose some people to pollen and track their reactions. And crucially, you control the variables so you know what's really causing the effect. Now fifth step, analyze the data. Once your experiment is done, you look at the result. Did what you expect to happen actually happen? Are your findings consistent? Do they support or disprove your hypothesis? Now the sixth step, draw a conclusion. Now you decide, was your guess right, partly right, totally wrong? Either way, you learned something. And that's science. Now the seventh step, share and repeat. This is what makes science unique. It's not just about one person's result. Other scientists can try the same test. If they get the same result, that's powerful. If not, it sparks new questions, and the cycle begins again. That's how we went from guessing why things fall to measuring gravity, from wondering about diseases to creating vaccines, from myths about the sky to landing on the moon. The scientific method is slow, deliberate, and sometimes messy, but it works because it's based on reality, not just wishful thinking. Now that we have seen how science works, it's just as important to understand what doesn't count as science, even if it sometimes pretends to be. First off, science is not opinion. You can believe that Earth is flat, but science asks, what does the evidence say? And the evidence from satellites, ships disappearing over the horizon, and the physics of gravity clearly shows it's round. Second, science is not belief or faith. Belief accepts something without evidence. Science demands evidence first. It doesn't ask you to trust, it invites you to test. Third, science is not fixed. It's not a frozen list of truths. People often say, but science keeps changing its mind. Yes, and that's its strength. Science adapts new information. That's what makes it self-correcting. Fourth, science is not about certainty. It's about probabilities, not absolutes. A good scientist never says this is a 100% true forever. Instead, they say, based on the current evidence, this is the best explanation we have. Lastly, science is not a conspiracy. It's not a secret club. Scientific results are published, peer-reviewed, repeated by others. If something doesn't hold up, it gets thrown out. That's the opposite of a cover-up. So if something demands blind faith, resists questioning, or can't be tested, it's not science. Science isn't one big monolith. It's a vast network of connected fields, each exploring a different piece of the puzzle. Think of it like a tree with many branches, all growing from the same root, curiosity. Let's start with the big three natural sciences. Physics is the study of matter, energy, space, and time. It explains everything from how your phone works to how stars are born. Chemistry zooms in on atom and molecules, how substances interact, combine, and transform. From baking bread to rocket fuel, chemistry is behind it all. Biology studies living things, how they grow, evolve, and survive. Whether it's plants, animals, bacteria, or humans, biology helps us understand life. Then there is earth science, which includes geology, meteorology, and oceanography. It helps us understand earthquakes, weather changes, and climate changes. Astronomy helps explore space, stars, planets, galaxies, black holes. It's one of the most oldest sciences, and still one of the most mysterious one. Social sciences like psychology, sociology, and economics look at people, our behavior, our relationships, and how societies function. They may use different tools, but the goal is the same: to understand patterns and causes. Formal sciences like mathematics and logics are a little different. They don't test nature directly, but they provide the essential language and structure that all other sciences depend on. Each branch tackles different questions, but they all share the same method, and often they overlap. Biology uses chemistry uses physics, physics relies on math, and all of them use observation, testing, and curiosity. That's the beauty of science. It's not just about specialization, it's about connection. Let's talk about something that often confuses people: why science changes over time. You have probably heard it before. Someone saying, first they told us eggs were bad, now they are good. Scientists can't make up their minds, or they said Pluto was a planet, now it's not. And the truth is, yes, science does change, but that's exactly what makes it powerful. You see, science isn't about getting everything right in the first time. It's about getting closer to the truth over time. That means revising, improving, and sometimes tossing out old ideas. Think about how we once believed the Earth was the center of the universe. It made sense at the time. Everything looked like it was revolving around us. But then, better telescopes and better math showed up. Same with the disease. For centuries, people believed in the miasma theory, the idea that bad smells cause illness. It wasn't until scientists discovered germs, through careful observation and experimentation, that their entire understanding of health changed. When science changes, it's not because it's broken. It's because it's working. It's self-correcting. It admits mistakes. It updates its model. No other systems of knowledge does that as rigorously. In science, new evidences doesn't mean failure. It means growth. That's not a bug, it's a feature. When people think of science, they often imagine logic, data, and cold hard facts. But they often forget something just as important: imagination, creativity, curiosity. Because before there's an experiment, there is a question. Before there's a data, there's a wonder. Every great scientific breakthrough started with someone who looked at the world and said, that's odd. Newton saw an apple fall and asked, why down? Einstein imagined riding a beam of light and asked, what would I see? Marie Curie wondered why some materials gave off invisible energy and discovered radioactivity. Science isn't just about crunching numbers, it's about thinking in bold, unusual, even playful ways. Einstein once said, imagination is more important than knowledge. Because knowledge tells us what we already know, but imagination, that's how we explore what we don't know yet. Even the scientific method itself requires creativity. Designing experiment, that's creative thinking. Finding patterns in a data, that takes insight. Curiosity drives the questions. Creativity drives the methods. Science is often portrayed as robotics and emotionless, but behind every experiment is a deeply human desire to understand, to make sense of the chaos, to connect the dots. And guess what? That means anyone with curiosity and a questioning mind has what it takes to think like a scientist. Here is a question people often ask: isn't technology the same as science? The short answer is not quite. They are connected, but they are not the same thing. Think of it like this: science explains, technology applies. Science tries to understand how the world works, why things fall, how diseases spread, what atoms are made of. Technology takes that understanding and builds something with it: phones, planes, solar panels, microscopes, vaccines. Science gave us the laws of motion. Technology used those laws to build rockets. Science revealed the structure of DNA. Technology used that knowledge to create gene editing tools. You can have technology without fully understanding the science. Early humans made fire without knowing the combustion chemistry. But the deeper our scientific understanding, the more powerful and safe our technology becomes. And it goes both the way. Technology also helps advance science. More powerful telescopes let us see distant galaxies. Supercomputers help us model climate change. Technology is both the tool and the result. But here is the important thing. Science asks why. Technology asks, how can we use this? So next time you hold a smartphone or step on a plane, remember, it's not just the result of a clever engineering. It's the fruit of centuries of scientific discovery. Now let us be honest about something. Because no guide to science is complete without it. Science has limits. And that's not a weakness. It's actually part of what makes science honest. So, what can science do? First, science can't answer every question. It can tell you how gravity works, but not whether falling in love is better than staying single. It can study brain activity when we listen to music, but not explain why a certain song gives you chills. That's because some questions are about meaning, not measurements, about values, not variables. Science can study what it is, but not necessarily what should be. Second, science can't prove things with absolute certainty. We often say science has proven, but technically science doesn't prove it. It supports with evidence. It builds strong models, but it always leaves room for revision if better evidence comes along. Third, science can't make moral or ethical decisions for us. It can tell us how to build nuclear power or nuclear bombs, but deciding whether to use the technology, that's a human choice, a philosophical one, a political one. And finally, science can't eliminate uncertainty. It can reduce it. It can help us predict. But the future always has unknowns, always will. So if you ever hear someone say, science can solve everything, be skeptical. And if you hear someone say, science doesn't know everything, be even more skeptical. Because admitting its limit, that's a part of what makes the science trustworthy. It doesn't pretend to have all the answers. It just keeps looking. Now let us bring it home now with the question that matters most to the most people. Why should I care about science? Well, take a deep breath. Right now, you are able to do that because of biology, which helped us understand lungs, blood and oxygen. You're listening to this video through a phone or computer, thanks to physics and engineering. You drink clean water, take medicine, check the weather, avoid disease, use GPS, fly in planes, cook food faster, and turn on the lights, all because of science. But it goes deeper than technology. Science changes how we think. It teaches us how to be skeptical, but open, curious, but careful. It encourages us to ask questions, to look for evidences, to challenge our own assumptions. In a world full of misinformation, quick fixes, and loud opinions, science gives us tools to slow down and ask, what's really going on here? It teaches us how to think, not just what to think. And the best part, you don't need a lab coat to be a part of it. When you wonder why leaves change color, when you notice a pattern in the stars, and you test a theory while baking cookies, you're doing science. You are a part of a long human tradition of curiosity. So, what is science? It's not just a school subject or a career path. It's not a collection of facts or a pile of inventions. Science is a way of seeing the world, a way of asking questions, testing ideas, and staying open to new answers. It's creative, it's imperfect, it's endlessly evolving, and it belongs to everyone. You don't need to memorize formulas to be scientific. You just need to stay curious, to observe, to ask why, to wonder, because that's where all begins. Whether you are 8 or 80, whether you are solving mystery or just trying to understand how toast works, science is your companion. And in a world as big and complex as ours, that might be the most powerful tool we have. Thanks for watching. Stay curious and keep exploring.